Hello everybody, I shall finish this math season 2 with the solution of problem 9. I was not able to solve problem 8 and problem 10. And as I announced, there will be no more competitions. I shall only publish starting from September something like problem of the week. There is no sense, only one person besides myself was participating in active solving, so I think that I really need at least 5,000 subscribers to make this sense, and if that happens one day, I shall gladly continue with some competitions. Until then, we shall simply try to learn some math and have fun. And this problem 9 is probably the easiest one of all problems here. We have three mutually disjoint circular regions. Their centers lie on one line. And we have another circle which touches all these circular regions, and we need to prove that its radius is greater than the radius of at least one of the first three. And we shall now see that this is really easy. So if we have three circles which centers lies here on this one line, for example here, here and here, let's say one circle here, one circle here, and one circle here. Then if we have another one which touches all of them, then one case can be something like this. Okay, not great picture of myself, but in that case, that fourth circle is very large, and its radius is obviously greater than any of the radius of any of the first three. So the worst case is the case when the smallest circle is here in the center, something like this, and two bigger circles, one on the left and another on the right, and so centers here and here, here. And if we have fourth circle which touches them, something like this. And it's now pretty obviously that this is at least greater than this one, the smallest one. Actually, obviously, we would say from the picture, but let's prove this strictly. So let this be the center of this fourth circle, and we shall now simply look at this triangle. Here, let me call this triangle, okay, we can call this S1, S2, and S3 as centers of three circles, and this could be S. So we will be looking at the triangle S, S1, S3. So this is R1. This is also R1, radius of the first. Here we have R2, radius of the second circle. This is R3, radius of the third circle, and this fourth we denote its radius by r. So we know the basic triangle inequality, the sum of two sides of the triangle, so SS1 plus SS3 is greater than the third side of the triangle, greater than S1, S3. But this one is simply R1 plus R. This one is simply, okay, here we have R and R3, so this one is R plus R3, and this is greater than S1, S3, but S1, S3 is greater than or equal to it's greater than 3 radius. This plus this plus this. So this is greater or than or equal R1 plus R2 plus R3. So what we have obtained, plus 2R2. We can take 2R2 because we can also take this. It was stated in the problem that first three circles are mutually disjoint, so they do not overlap, and we have this. And now we can conclude, we can simply cancel R1 here on the left and R1 here on the right, R3 here on the left and R3 here on the right, and what is left is 2R here greater than 2R2 on the right, and when we divide with 2 we obtain that R is greater than R2. So we simply concluded what we stated from the picture, that this red circle has a radius R which is greater than this R2, this radius of this smallest circle which is in the middle between those three whose center are on the same line. So, thank you. I hope that we shall have some more fun soon with mathematics, and goodbye till then. Happy summer.